Well, today let's just look at review because we have our exam 2 coming up next time. This will be open book and open notes, just like the first exam. And of course, you can use your computer, just no help from any people. And during the class time, I'll send it out by email and recover it by email within an hour and a quarter. This will be covering chapter 6 only this time. We got into chapter 7. I'd like to do a little bit of it, but I think it'd be a little disjoint. So let's just do chapter 6. That's what I put the review problems out on. Most problems similar to the review problems. If you're very good at doing all those kinds of problems, you'll be able to pass the test. However, I may put some that are similar to homework problems that aren't there. The review section is really for the major concepts, but there are some other things I might like to put on there too. So the review set is on D2L. If you haven't downloaded it, take a look at it. Come by my office hours, ask me questions as you have them. All problems similar to homework, which is almost all of the problems in chapter 6. So pretty much you just have to be able to do all the problems in the UCO supplement on chapter 6. Any questions on the test then? So for today, we'll just do review, although if you have any questions on chapter 7, I'm willing to entertain those for a while too, what we were doing last time before we get going on review. Anybody online? I want to ask a question either. Looks like the speakers are up, you can interrupt anytime. Well, let's see what we want to do on the review. I've got a copy of it here, if you want to do anything in particular. Have you looked at these? Is there anything that's difficult that you want to look at?
The one I'm having issues with is the 1A. Because I get like a square, like a pi squared over like 6, and I don't know what to do with it.
1A is a graph, is it?
Yeah, but you have to like do.
Okay. Okay, let's look at 1A. Oh, maybe I have the wrong problem. Sketch the graph and plot at least 5 exact points over at least 2 periods. Suppose I have y equals 2 sine pi over 3x minus pi over 2 plus 1. One of the nice things about this is if you have your graphing calculator, you can go ahead and check it on there. However, that will not get you the 5 exact points, right? So you have to be able to do this by hand and then check it by your calculator when you're all done, because they'll do a nice job. If you don't have a graphing calculator, you can use online software. I'll just point out the software by Symbolab does it online. You can put it into their graphing thing, or there's lots of other graphing packages online. I like this one, Spec Mathematics. You can download their application, then you don't have to count on their online calculator.
Professor?
Yeah,
Can
I'm
you
on
move
the
to
wrong
your
part of
mic
the
a little?
screen. Yeah, I'm sorry, I forgot to move it. Yep.
You're good.
Thank you. Just testing to see if your speakers are working, of course, right? All right. So, but if you download this, you can do these applications, these plotting things. For instance, to do this one, you could say plot 2 asterisk for time sine parenthesis pi slash for divided by 3 times x, and we'll do the divide before the multiply, so it works out. Minus, oops, instead of pi, you've got to put pi, minus pi divided by 2, close, plus 1, close. This command on the spec thing, for instance, will plot this nicely. Again, it won't show you exact points, but if you don't have a calculator, you can do that. So I'll just say check by calculator, one of these online software packages or one of these download software packages. This is the command for this one. It's very similar to the calculator commands. All right, So what you do here is you pick off the 4 letters. You think of this as A sine bx minus c. So this is plus pi over 2 is c. It's whatever's subtracted here. Plus d, whatever's added here. From the 4 letters, you get 5 properties, right? 1, you get the amplitude. The amplitude is always the absolute value of A, not A, it's the absolute value of A, right? So it's 2 in this case, same as A. 2, you can get the period, P, which is 2 pi over B, right? Where B you just read off. I should point out on the handout here, it says, well, I guess that one comes out right. Some of these I use the slash for divide down in problem 3. All right. Make sure you can read those okay. 2 pi over B is the period, and B is pi over 3, so it's 2 pi over 3. And now you've got to be careful with your divisions. Again, write that as 2 pi over 1 all over pi over 3. Now it says top times bottom, 2 pi times 3, over middle times middle, pi times 1, and the pi's cancel. So the period is actually 6.
Okay, I have a quick question. So when I was looking over this, I saw like on several different websites, different math things.
Yeah.
They said you have to have the x by itself before you can do anything. Is that right or is that wrong?
I'm not sure what you're saying. Are you saying write it like this?
Like, yeah.
Y equals 2. Let me try this and see if this is what you mean. Pi over 3 x minus oh boy, 3 halves plus 1.
Like you have to factor out the pi over 3 before you can do anything.
Oh, yeah, so that would
Like
be like this then.
divide by the reciprocal.
Yeah, there are 2 ways to do this. One of them is to do a sine bx minus c plus, actually it's 3 ways. One way is change this to a plus and then say the phase shift is minus c over d, instead of we should make this a subtract and the phase shift is plus c over d. The other way is to write it like this instead of like this. So it's b times x minus c, and in this case, this is the phase shift. If you write it like this, this becomes, so that any equation of this form, you can factor the pi over 3 out of here. This times this is pi over 3x, and this times this is pi over 2. Once you write it that way immediately, this is the phase shift, and you can just read it.
But you can keep the.
Yeah, if you leave it like this, then you have to compute the phase shift as c over b. If you rewrite it like this, then this is automatically the phase shift. Sometimes they call it phi. We don't have a letter for it in this class because we use the c over b. Yeah, so either way, and actually our book does it this way also. They give a couple problems in the beginning like this where you can read it. And what I usually do for this class is I multiply it out and put it in this one. And let's say the phase shift is c over b, but both ways work just as well.
Okay.
Yeah.
Thank you.
Well, and the reason they do it this way is what we were commenting about graphs. If you have y equals x squared, and you want to know what if I replace x by x minus a number? What does y equals x minus 2 squared look like? It's exactly the same shape moved over 2 units, so it now has a vertex at 2 instead of at 0. But it's the same shape. And this one, you're thinking, well, if I just had 2 sine pi over 3x, it's a shift of 3 over 2, and it shows you the phase shift right off. But it's just if you like to think of this thing, replacing x by x minus a number is the phase shift. Maybe that's too long an answer, but both ways work is the point. I've been doing it this way for the class, and books do it both ways. All right, so there's the amplitude, there's the period. Now what we want is the phase shift, also known as the horizontal shift, but engineers use this term, so we'll call it this, and mathematicians too, I should say. The phase shift is always c over b. If you write it in the other form, it's just the phi, you just read it. C over b is then pi over 2, whatever is subtracted up there, divided by pi over 3. The pi's cancel since they're both numerators. You take top times bottom is 3, over middle times middle is 2. You find the phase shift is 3 halves. So from the 4 letters, we deduce 5 properties. Here's the 4th one, the vertical shift. That's always D. Just whatever you add on the end moves it up and down, right? Is equal to 1, so it moves up 1. And then finally, is there a flip? If A is negative, there's a flip. If A is positive, there's not. Here, A is positive. So we say no, A is positive.
Wait, shouldn't that be, the phase shift, shouldn't that be 2 over 3?
If I multiply it out, I take top times bottom, because this is 1 times pi, 1 times 3, over middle times middle, 2 times 1, and so I get 3 halves. That's why I always recommend writing these out as a quotient of quotients, right? Pi over 2 over, let's write out extra steps.
That's what the
If you
phase
cancel
shift.
the pi's, it's 1/2 over 1/3. All right, and then you take top times bottom is 1 times 3 over the middle times the middle, or you can write it as the top times the reciprocal of the bottom, and either way it's 3 halves. All right, so the phase shift is 3 halves, and vertical shift is 1, and there's no flip. So there's the 5 properties. Now I can sketch this. Oops. And the thing to do on the sketch is normally at least is to start with the shifts, because what happens is a shift and a stretch. If you stretch it first, or if you, the only point that shifts this amount in both directions is the origin, and then the stretch changes that for the other points. So we move it up 1 and over 3 halves. There's 1, 2, 3, 4, 5. So over 3 halves and up 1. And we have this shift point, 3 halves 1, the horizontal shift followed by the vertical shift. Then from there you can say this is the midline, it always goes through that shift point. Then look at the amplitude and go up and down by the amplitude, 2 units, 2, 3, 0, -1. And draw a guideline, amplitude above and amplitude below midline. Then if this is a sine function, it goes through the shift point. If it's a cosine, it starts at the top or the bottom guideline, above or below the midline. Since it's sine, we'll put it right through there. Since there's no flip, we'll do it like the natural sine. It just goes right through going up. If it's flipped upside down, it has to go down this way. So there's a right side up, a no flip sine goes through the shift point. And now the period is 6, so I have to go over 6 units, and hopefully I left enough round way over here, maybe I didn't. But 6 plus 3 halves, right? You have the phase shift plus the period. Well, this is 12 halves plus 3 halves is 15 halves. That's where it completes 1 period. So if this is 3 halves 1 period later, 6 units at 15 halves, I reach this point again. So 15 halves 1 right here. And now I draw the sine wave up to the top, back to the middle halfway between these points, down to the bottom guideline, and back to here. And there is 1 period of the sine function. I said draw at least 5 exact points over 1 period. So here's 1 period. Start from my shift point, go 1 period up to the next spot there. Now we can find the rest of the points easily, right? It crosses halfway between. So what's halfway between 3 halves and 15 halves? If you think about it, you're asking what's halfway between 3 and 15. They're 12 apart, so it must be 9. This must be 9 halves 1. Right? So halfway between 3 and 15 is 9. The other way you can do it, if you want to compute it, is just to say you average those x-coordinates. 3 halves plus 15 halves all over 2 is, let's see, 18 halves over 2 is 18 over 4 is 9 halves. So you can compute it by averaging them. Will always be the point halfway in between. And then halfway between 9 halves and 3 halves, well, halfway between 3 and 9 is 6. So this must be 6 halves, also known as 3. So we have this point at the top, 3, and the height of there is 3. And then halfway between here and here, between 9 halves and 15 halves is 12 halves, also known as 6. So this point must be 6, and it's the bottom guideline minus 1. There's 5 exact points. 1, 2, 3, 4, 5.
So how did you find the 3 on the top?
Oh, yeah. I found the x-coordinate by averaging these 3 halves and 9 halves. Right? I just add them and divide by 2 and I get 9 halves. Or easier, I might say halfway between 3 halves and 9 halves is 6 halves, right? Halfway between 3 and 9 is 6. So I find the x-coordinate by averaging these two. Then the y-coordinate, I just go to the top guideline because I know I'm at the top. Right. The idea is I cross the midline here, I cross the midline here, and I know that halfway in between, I reach the top guideline, which I've already computed as 3. That way we have an amplitude 2 above the midline. Any other comments? Now, it did say one more thing on here. I said plot at least 5 exact points over one period and show at least 2 periods. So what do I do for the second period? Easiest thing to do, you can copy it on that side or on this side. It doesn't matter. Just go back down to the bottom. Back up to the middle and just draw exactly the same shape. I didn't ask for 5 more exact points, but you know that the period is 6. So you just go back 6 over here. And if you wanted to plot this point exactly, you'd then say this is 3 halves minus 6 is minus 9 halves, right? This is 3 halves minus 6, minus 1 period, which is 3 halves minus 12 halves. When you put them over common denominator, is minus 9 halves. If you do this enough, you can do it in your head, but otherwise you have to do it on the calculator or something. So I only ask for these 5 exact, but just make a copy of that over here and I'm happy. Look okay? Sometimes it's harder to go the other direction. I'm going to do one the other direction. That's problem 2. But there's 2 things, 2 major concepts you want to get out of this chapter. One of them is graphing trig functions, and the other one is using inverse trig functions. So graphs and trig functions using inverse trig functions. Thanks for the problem. And these are the major concepts in here. So suppose I have this graph at number 2. This is kind of tricky. I graphed on a machine, so it has a frame around it. But down the middle are the x and y axes on this one, right? So this is the x-axis. This is the y-axis. And it starts exactly here that I marked minus pi. And it ends exactly here and I marked pi. And if you look at it, it goes exactly through 0, 0. It goes right through the orange. And the idea, let's see. A little steeper than that. It's a little hard to recreate the picture sometimes. It doesn't go to the top in here, just like that. And it goes up to 2 here on the y-axis, and down to minus 2 here on the y-axis. Something like that. Now the question is, what equation has that graph? We got to go backwards. Use the 5 properties to deduce the 4 letters and write the equation. What's the equation for this? Since it's a sine wave, you can use either sine or cosine for this. They both work, actually. I'm going to look for y equals a sine bx. So use 5 properties to get the 4 letters A, B, C, D for sine equation. Y equals a sine bx minus c plus d. How can I do that? I look for exact points, and there are really only 3 points that I can tell exactly on here. This one almost crosses at -1, but not quite. It's a little aside, so that's not an exact point, right? But it goes right through the origin, it goes right through these 2 points at plus and minus pi. And so those, and the same thing over here, this doesn't quite go through 1. And so those are the points I want to use to get the exact equation. If I take one of these 3 points that I know exactly is a shift point, then I'll get it. Now, if you knew an exact point at the top or the bottom, you should use cosine to write the equation for the wave, because the shift point on cosine corresponds to the top or bottom point. But if you're taking the exact point at the middle, then you should use sine. So I'm going to use sine and write an equation like this. I can choose any one of these 3 that I know exactly. Let's choose 0, 0 for the shift point. But the shift point, we know, we just memorized it. The book doesn't call it the shift point, it calls it horizontal shift and vertical shift. Is C over B and D. Just on the camera still, maybe to move it just a little bit, huh? And so I know immediately that C over B is 0 and D is 0. Now, if I'm choosing this as the shift point, then I'm going to use sine because it's on the midline, which is the equation I wrote there. A sine dx minus c plus d for shift point on midline. However, I noticed something interesting about this graph. Since it goes down through the origin, it's an upside down sine wave. Right side up, it would come up through the origin through its wave. With a less than 0, since it's flipped.
Can you shift the camera a little bit more?
Yeah. Sorry about that. All right, and now we look at it's going up and down between plus and minus 2. The amplitude is then 2. The amplitude is the distance from the midline to the top, not from the bottom to the top, from the middle of the top, or from the bottom to the middle. So I'll say amplitude is absolute value of A is evidently 2 units, just from looking at the graph. And you have a flipped wave, we just said. So A must be -2. Has to have absolute value 2. It has to be the flipped case, so A is -2. Now the period you can rewrite off, right? This one is a tricky one on the period. It's hard to say. It looks like it does 1 period coming from here and about 2 units, but not exactly. It doesn't land right on the 1. But I do see this 1 period, 2 periods, 3 periods as x goes from minus pi to pi, right? So 3 periods is actually equal to, from here to here, 2 pi. Exactly, right? Between those 2 points I know. That tells me that the period is 2 pi over 3. So the 5 properties I get from the graph are 1, it's flipped, 2, the amplitude is 2, and 3, the period is 2 pi over 3. And then also the shift point is 0, 0.
Wait, where did you get the 2 pi from?
Oh, from taking from here to here, minus pi to plus pi is 2 pi. And all I'm saying is it does 1, 2, 3 waves over 2 pi, over a length of 2 pi. So 3 periods equals 2 pi. All right, now I can get it, right? Because I look here, amplitude is 2, and it's flipped, so A is -2. That gives me A. The period is 2 pi over 3. But the period is also, recall, 2 pi over B for every sine wave. So if 2 pi over B equals 2 pi over 3, we can flip those and get B over 2 pi equals 3 over 2 pi, and then we can cancel the 1 over 2 pi on each side and say, oh, B equals 3, right? So there's A and B. Now what's C? From the beginning equation, we have 0 is C over B, and B is 3. So if C over 3 is 0, that tells me that C is 0, right? Multiply both sides by 3. Then D is the vertical shift, but there is no vertical shift, right? The midline is right at 0. And we look at it from the shift point. D equals 0 from the shift point. And I've got it. I start with my 4 properties and deduce 5 properties and deduce my 4 letters. Now I just fill in the equation, right? So now I write y equals A was -2, sine B is 3, x minus C, where C is 0, plus D is 0. And then it's nice to simplify this, but you can just write y equals -2 sine 3x. Then graph it on your calculator, see if it looks right. Make sure your calculator's in radians mode when you do the graphing, or it won't look right.
So when you're trying to find B, you always use the period to kind of multiply it out.
Yeah, you look at the period on the graph, and then you set whatever that period is equal to 2 pi over B, and that'll tell you B. And you look at whatever the amplitude is, and that'll tell you A to within plus or minus. Just the same process every time. All right. There's also some secants and tangents here. I don't know if you're interested in those or not. Maybe I should look at 3A briefly. Suppose instead of a sine or a cosine, I want a secant. Y equals 4 secant x over 2 plus pi over 4. I wrote it like that. And then I said on the interval, minus 5 pi over 2 to 3 pi over 2. This slash is another way of saying divide. What this really means, I hope the notation was confusing, is 4 secant 1/2 x, or x over 2, plus pi over 4 on the interval, minus 5 pi divided by 2, 3 pi divided by 2. And then this interval notation means the left endpoint less than or equal to x, less than or equal to the right endpoint. So this is the interval I'm going to plot on. And by the way, if I put a round bracket here, what does that mean?
It doesn't include.
Yeah, it means it doesn't include the endpoint. Then you put strictly less down, right? So this one includes the endpoint. This one is no harder than the first problem we did. Here's why. To sketch a secant or a cosecant, you first sketch its reciprocal with the same letters. Sketch the reciprocal function using the same letters. So this is like problem 1, except with a cosine. I say y equals 4 cosine is the reciprocal function 1/2 x plus pi over 4. This must be a that multiplies the cosine. This must be b that multiplies x. C must be minus pi over 4 because c is what's subtracted in here. And there's nothing added on the end, so I put plus 0 and call that p. Let me erase this part. Now from the 4 letters, we get the 5 properties. We say the amplitude, I'll do it quicker this time, is absolute value of A is 4. The period of a sine wave is 2 pi over b, whether it's sine or cosine. Assume b is positive. If it's not positive, use the even property to fix it, get rid of the minus. This is 2 pi over 1/2, and you have to be careful the 2's don't cancel, right? This is a numerator, this is a denominator. You think of it as 2 pi over 1, all over 1/2. Top times bottom is 4 pi over the middle times the middle, 1 times 1. Makes the period 4 pi, the 2's reinforce each other, right? Amplitude, period, there's a phase shift, which is always c over b. So we just read it. C is pi over 4 over b is 1/2. Again, top times bottom, 2 pi over the middle times the middle, 1 times 4, gives you pi over 2 as the phase shift, right? Then there's a vertical shift of d. That's 0, so there's no vertical shift. Flip, no, because A is positive. Is that on the screen, I guess, yeah. So there's the 5 properties: amplitude, period, phase shift, vertical shift, and flip. I go over and plot that one. I said, boy, it's taking a long time. I'm not even getting to the secant function yet, right? But the shift then, let's see, pi over 2, nothing. So I go to pi over 2 here, up 1.5. And there's the shift point, no vertical. I go up and down by the amplitude, just like in the first problem. 1, 2, 3, 4. Draw the top guideline. Down 4 units. 1, 2, 3, 4. Draw the guideline down here. Then I notice the period is 4 pi, so I add 4 pi to this one. Coming out here at pi over 2. Well, this is 4 pi length. Come out here to the point at pi over 2 plus 4 pi. We can figure that one, right? This is pi over 2 plus 8 pi over 2. Right, rewriting with a common denominator, multiply this top and bottom by 2. Gives us 9 pi over 2, right? 1 and 8 is 9 pi over 2. So we'll have a point right here corresponding to this one at pi over 2. Now we don't start with the function going through the shift point. Where does it start? It's a cosine this time, right? So it has to start at the top if it's unflipped, or the bottom if it's flipped. So instead of driving through the shift point, I go to the top, and the cosine starts right here at pi over 2 with whatever the value of the guideline is, 4 in this case. Which means over here, when it completes a period, it's 9 pi over 2 and 4 again. Now what I need, is a cosine wave. It goes all the way down to the bottom, back up to the top for one period, starting at pi over 2, 4, and finishing at 9 pi over 2, 4, 4 pi units later. I can get 5 exact points pretty easily. For instance, this one's halfway between, we know. So it's halfway between pi over 2 and 9 pi over 2. Right? You just average them. 5 pi over 2. Halfway between 1 and 9 is 5 pi over 2. So this point down here is exactly 5 pi over 2, and it's at the bottom guideline, -4. Now that's all great, but the instructions said plot this on the interval -5 pi over 2 to +3 pi over 2, so I don't even need this point. I only need to go here to the point halfway in between, right? Pi over 2, 5 pi over 2. Halfway in between is the crossing point. It must be 3 pi over 2, 0. So I'm going to finish the graph right there. And then I have to graph back to -5 pi over 2. So that means I need to continue this thing. These look like it goes from here to here in pi units, and then pi units, and then pi units, and pi units. It's period 4 pi, I guess. All right, so pi to here, pi to here, pi to here, pi to here. So we can go back pi, crossing at -pi over 2. Back pi more to -3 pi over 2. And then it's at the bottom guideline, -3 pi over 2, -4. Let's see, I'm supposed to go all the way back to -5 pi over 2, so it comes back up then to here, another pi units. -5 pi over 2, 0. There it is. Now, that's what I need then is just the interval -5 pi over 2 here, to 3 pi over 2 here, so I can erase the rest of this now. I just scribble it out just to show that we did it. And we'll just take that portion of the function. Now, all that work just to get the cosine, how do we draw the secant? Once you've drawn the cosine, it's reciprocal. Secant with the same letters is trivial. You put a asymptote everywhere the cosine crosses its midline because the secant isn't defined there, right? 1 over the secant is 1 over the cosine. If the cosine is 0, then the secant is undefined. So at x equals -pi over 2, this x coordinate, we have an asymptote. Similarly here, at x equals 3 pi over 2, we have an asymptote. Then what you do is the secant needs to just touch the peaks and valleys of the cosine. That's why once you draw the cosine, it's easy. Just put asymptotes everywhere the cosine crosses midline. And draw these U-shape down, U-shape up to the peaks and valleys of the cosine. Same thing with secant, with cosecant and sine. Actually, I don't even need this, do I? Because this was erased. So I just need this part, this one and this one. Right? And I go from -pi over 2 to 5 pi over 2 to 3 pi over 2.
Is it the same for tangent? It's the peaks and valleys of tangent?
Tangent is unfortunately different. For secant and cosecant, you do this because they're the reciprocal of cosine and sine, respectively. So for the reciprocal function, secant and cosecant, this is what you do. Okay, let's run it back to the other side then. Anything in particular anybody wants to look at out of the rest of this?
What does it mean by find like the exact expression, like on 6?
Yeah, okay, so the question is, find an exact expression on 6, what does that mean? Let's do 6a. Find an exact expression for the tangent of the arc cosine of x over x plus 1. I might have done this exact one before. We did one kind of like this. Whenever you have a trig function, an inverse trig function, I want you to recognize that can be done exactly regardless of what the angle is. You don't have to have a special angle to do a trig function of inverse trig function. The other way, inverse trig of trig, you do. But this has a neat algebra trick. When you see that, do these 3 steps. One, make a right triangle with the inverse trig function that you see there. Whatever it is, in this case, it's the arc cosine of x over x plus 1.
That's how it's always gonna be.
Yeah, always make it the inverse trig function that's there. Now, if theta is the inverse trig function here, you can put in a right triangle, because within the right triangle, this is equivalently, take the cosine of each side, cosine of theta equals cosine of the right, cosine undoes the inverse cosine of the triangle, gives you x over x plus 1. So take the cosine of each side and get that within a triangle. And now I can sketch that in the right triangle. If I want this angle to be theta, for instance, in a right triangle, then this must be the adjacent and the hypotenuse. This is x, and this is x plus 1. So that's step 1. You can also use 2x and twice x plus 1, but who wants to cancel the 2's later? So just do the easiest, right? Just so they have this ratio that works. Now you need the Pythagorean theorem to find the last side. This one. Well, it's a leg, so it's square root of hypotenuse squared minus the other leg squared. Square root of x plus 1 squared minus x squared. And you FOIL it out, we said. And get x squared plus 2x plus 1. Subtract x squared. And then the x squared and minus x squared cancel. It's just the square root of 2x plus 1. There's the last side of the triangle. Now we can find any trig function of inverse trig function of x over x plus 1. Step 3 is just use the triangle to evaluate the expression. Tangent of the arc cosine of x over x plus 1 is the tangent of theta, because we drew the triangle that way. All right, we made theta the arc cosine. What's the tangent of theta? It's the opposite over the adjacent. Well, that's theta. Opposite is root 2x plus 1, and the adjacent is x. There it is. So marvelously, the tangent of the arc cosine is actually of x over x plus 1 is actually this algebraic expression, surprisingly, right? That's what happens with trig functions of inverse trig functions. I will ask you somewhere along the way to evaluate an inverse trig function exactly. And again, your calculator can do this, but I want you to check it out. I might ask you to draw a picture or something, at least to show some work of some sort. Suppose I want to find exactly the inverse sine, this is 5b, of 1/2. Remember how to do that? Have to be able to do these in higher mathematics also. When you ask what's the inverse trig function of a number, it's equivalently asking what angle within the range of that inverse trig function. For inverse sine, that means it's minus pi over 2 to pi over 2. Has that sign. All right, ask you what angle has this sign in this range? There's only one answer in this range. So you draw the unit circle and say sine is the y coordinate, so we need the y coordinate equal to half. Let's put it halfway to the top of the unit circle. Observe that these are all y coordinates at half, so there's only 2 points on the unit circle with y coordinate equal to half. There and there, which means only 2 terminal rays can occur with sine theta equal to half. Now you can see it, because if you want theta also be between plus or minus 90 degrees, right, minus pi over 2 and pi over 2 radians, that throws out this one. It can only be this one, and it's this angle right here. What is it?
Pi over 4.
Close. And the way I drew it, it looks like it, but it's actually not. This is where you have to draw it accurately. You fool yourself. Like this. What you do is you say it goes up to y equals to half. So this is 1/2 unit high. And this is 1 because it's a unit circle. Must be a 30, 60, 90. If this is a half and this is 1, the Pythagorean theorem would tell you this is square root of 3 over 2. So despite my poor drawing, it's actually supposed to be a 30-degree angle there. So pi over 6 is the answer on this one. On these, I'll normally have you do them in radians rather than degrees. So the arc sine of a half is pi over 6 because of this unit circle argument.
Okay, will you just explain one more time why you took out the second one?
This one?
Yeah.
Oh, because I'm asking, these are the only possible terminal rays. The arc sine is the terminal ray that goes with an angle between minus pi over 2 and pi over 2, minus 90 and plus 90.
Okay.
You can kind of remember it like this. Here's the graph of arc sine. Let's see, more room. Looks like that. Remember when you flip the sine wave. So whatever number number between -1 and 1 you put in, like we put in a half here, the angle that comes out can be no less than minus pi over 2, no bigger than pi over 2. It's the angle that has that sign that's between these two numbers. This is the graph of y equals arc sine x. You know, I forgot to mention on those first problems in the graphs, I did that with a sine function. There was an infinite number of solutions. You can add any multiple of 2 pi to that sine function, and because sine is 2 pi periodic, it will give you the same graph. And you can also do it with a cosine by shifting the cosine over. So if you got a different answer, it might still be correct when you work that. Just if you pick a different shift point, you'll get a different sine function. It'll be the same graph, just shifted 2 pi so they'll land on my graph. I put a good smattering of problems on here that I think are important. This next one I think is important also. Pretty much all these on the practice test are. I wish I could ask the whole thing, but the actual test will be shorter, right? It's too many problems to do in an hour and a quarter. Maybe we should do this one real quick, actually, first. Let's look at 5a. Arc sine is nice enough because you can say what angle has the sine and say sine is the y coordinate. But what if I say what is the arc tangent of -1? There's 5a. Now I'm asking what angle theta between minus pi over 2 and pi over 2 is also the range of tangent, except you don't include the endpoints. Has this tangent -1? That's a harder problem. Why is that harder?
Because it's not stopping at the endpoints.
Yeah, okay, so yeah, tangent is y over x. So you don't get to just plot like here's all the y coordinates, here's where the thing intersects. You have to have the y over x equal -1. How can you do that if you have y over x equals -1? There's lots of ways to do this. I like to write this as -1 over 1. And then say, this is not a y coordinate and an x coordinate of the unit circle. That's right, because it's 1 unit each, is going to be outside the unit circle. So how do I make a ratio like this that's on the unit circle? You divide the top and bottom by the root sum square, -1 squared plus 1 squared. is square root 2. If you divide these by square root 2, then this square plus this square, by their root sum square, then this square plus this square will be 1, and hence they'll lie in the unit circle. The unit circle equation is x squared plus y squared equals 1. So you divide by this, then this square plus this square will be equal to 1. It's on the unit circle. So we'll say that this now, if I divide top and bottom by the root sum square, this can be interpreted as y, and this can be interpreted as x, of an x-y point on the unit circle whose ratio is -1. And last, there's another one. What's the other one? What's the other ratio minus 1 that's on the unit circle? You could use minus this over minus this, and the minuses would cancel, right? You could put 1 over square root 2, positive on the top, and negative on the bottom, -1 over square root 2. This could be y and x, and this would also be in the unit circle. They're points directly opposite each other. And so the question is, see how it's harder than just doing this picture here with the line? The question is, which one is it? If you sketch the unit circle with these 2 points, x is positive and y is negative. 1 over square root 2 is something like 0.7. 1 over square root 2, and then y is negative 1 over square root 2. We wind up here. Or I can have y positive and x negative, right? 1 over square root 2 minus 1 over square root 2. I have at this point, and they're directly opposite always, tangent, cotangent. Which angle is it? This is where this comes in. The arctangent is the angle in this range whose tangent is this. Both these angles have the correct tangent, and you can go all the way around 12 times, right, and then to here, and that also has the same tangent. Any angle with one of these terminal rays will give you tangent -1, but when we restrict the tangent to angle between minus pi over 2 and pi over 2, first and fourth quadrants, then there's only one answer, and that's the one that's the arctangent. Arctangent is one angle in this range. So we throw out this terminal ray because it's not between plus and minus pi over 2, the values that arctangent can put out. It has to be this one, and you can't go all the way around this way because that's too big. That's bigger than pi over 2. It must be this angle right here, right? Well, what's that angle right there? Well, this, right?
Could be the same thing with 30, 60, 90. Could be 30.
Almost. Again, maybe my drawing. If you look at this, this is down, the y coordinate is 1, or the x coordinate is 1 over square root 2. So this side of the triangle is 1 over square root 2, and I make the reference triangle. And then this side goes down to minus 1 over square root 2. So this side is 1 over square root 2 in length, and this is 1. So it's a 45, 45, 90. 1 over square root 2 is also square root 2 over 2. So this will be a negative, since I went clockwise. 45 degrees is negative pi over 4 radians. See why you need to memorize these? If you have to convert it every time, it's been half the test doing that. So there it is. The arctangent of -1 is minus pi over 4 because of this unit circle argument. These are the only 2 possible terminal rays. They're the only ones that make tangent -1. The only terminal ray that corresponds to an angle between minus pi over 2 and pi over 2 is this one turned this way, right? Minus pi over 4. So you have to be able to do those. Again, you can check these on your calculator. A lot of these calculators, not all of them, will tell you exact answers. So check them, but I might ask you to show some work, show a diagram or something. So be able to do them by hand is the key. In the long run, if you can't do them by hand, there's always a problem with doing it by calculator. You get an advanced math class and you have to do it for a theoretical equation. It's not an exact number. It's a problem, but I can't ask those questions here. All right. Here's the other one I started to mention with 6b. I might have an inverse trig function of a trig function. Actually, let me do another one, a simple example first. Suppose I have the arc sine of the sine of 0.1. What's that? 0.1 is not even a special angle, but I know the answer.
It's 0.1.
Yeah, exactly. 0.1 because they're inverse functions. It's because the arc sine by its design, undoes the sign for angles x in that piece of the sine function we flipped, right? That is minus pi over 2 less than or equal to x less than or equal to pi over 2. Unfortunately, it gives you something else otherwise, right? And so 6b asks you the otherwise, unfortunately. What's the arc sine of the sine? But I could give you one like this on the test. Not a special angle, not a problem, right? If it's between minus pi over 2 and pi over 2. What's the arc sine of the sine of 7 pi over 6? It's not 7 pi over 6. How do we find it? There's two schools of thought on this. One of them is to say the arc sine is the angle that has this number is its sine. Oh, well, this angle has that sine. So what you're asking is, what angle has the same sine as 7 pi over 6, but is it between minus pi over 2 and pi over 2, a number that arc sine can be? So that's one way of thinking of it, is what angle theta in the interval minus pi over 2, pi over 2 that arc sine can put out has the same sign as 7 pi over 6. Right? So you sketch it. Here's 7 pi over 6. All right, how do I know it's about there? Well, 7 pi over 6 is pi, 6 pi over 6, plus one more pi over 6, right? Pi over 6. 6 pi over 6 is pi, straight angle. So it's right here, pi over 6 past straight angle. And now I say, what angle between here and here has the same sine? Sine is the y coordinate, so it has to have the same y coordinate. So it must be this one right here. This is the angle theta. That's the arc sine of the sine of 7 pi over 6. So what is it? Yeah, exactly, right, because 7 pi over 6 gives you a reference angle of pi over 6. Therefore, this angle by symmetry is also pi over 6, but that's counterclockwise. Clockwise, right, we have to go clockwise here because we have to have an angle between here and here. Theta must be minus pi over 6. So yeah, you look at this one is pi over 6, so this one must be pi over 6 by symmetry, and our angle in clockwise minus pi over 6. So you can do it that way, say that the inverse trig function of the trig function is the angle with the same sign, and just sketch the picture, what has the same y coordinates, what has the same sign. That's the most beautiful and quick way to do it. However, sometimes that's a little abstract, so I want to do the alternative method also. Alternatively, since this is a special angle, we can just compute it directly in the unit circle. Right? We can say the arc sine of the sine of 7 pi over 6. Well, what is the sine of 7 pi over 6? All right, it's this one right here. Let's write it over here. It leaves us a reference angle of pi over 6, just like over here. Made it look a little bigger than that, but which means it's a 30, 60, 90 triangle, 1/2 square root 3 over 2 of the length, 1. That means the sine of 7 pi over 6 is the y coordinate minus 1/2, right? It's the y coordinate, not the length here. See, this is the arc sine of minus 1/2, compute it, right? And now you say, what angle between minus pi over 2 and pi over 2 has sine equal negative 1/2? That's this question. What theta in this range of numbers has this sine? You move the camera, sine theta equal negative 1/2. I think that's got it. Well, now you look on the unit circle and y equal -1/2. There's two terminal arrays, this one and this one, but this one is in the wrong quadrant. Again, so you draw this a little better. You have this angle. Since if you drop the perpendicular, since it goes down to y equals -1/2, this side is 1/2. This side is 1 since it's unit circle. Oh, I know, the last side has to be square root 3/2, but Pythagorean theorem, this angle must be -5/6. Right? 5/6, 30 degrees, and then clockwise. So you can also get -5/6 just by computing it. A little longer, but less abstract. Right? Okay. That's a lot of interesting things I can ask, actually. I asked you to do calculator things. I asked when you do the calculator things, like on 7b, what is the arc sine of -1/4? Put your mode in radians, if I ask for radians. And then it's just to get an inverse trig function, you do second sine. And up above, the second key is in blue. It enables the blue instruction above arc sine, or maybe it's in yellow, it enables the yellow instruction. Parentheses are automatic, and so you just have to push the minus key on the keypad. 1 divided by 4. Some of them you need to close the parentheses and then enter. You might have to close it. Let's see what I get from there, but make sure the mode is in radians, or you get the wrong answer. I'm in radians already. So second sine to get the inverse sine, minus off the keypad.
You might want
Move the camera?
yeah.
Okay. Thank you. That time in there. All right, so these keystrokes again, and I get minus 0.25268, blah, blah, blah. And be careful, I'm liable to say round to so many decimal places. So it says round to 2 decimal places. That means start at the decimal point and go over 2 digits, minus 0.25. And then this digit is 4, let's just leave it. And if it's 5 or more, increase it. And so in this case, we have minus 0.25 radians. If you don't put radians, then I'll assume it's radians. But if you want degrees, you have to put the degree symbol. Now the applied problems. On those, the advice again is to draw a picture because often that gives you a hint, right? So we'll look at number 8 here. Actually, let's look at number 9. Oh, do you want? I think I already did this one for off the homework. Let me do a similar example then. Suppose I said a cliff face. This will be like number 8. 100 feet away, a vertical cliff face. Is 50 feet tall. What is the angle of elevation to the top of the cliff. This is similar to number 8, different sides of the triangle. So I'll take my own advice, draw a picture. I'm standing here. Here's 100 feet away and a 50-foot climb. Here's the angle of elevation, the angle up from ground level. So what is it? Once you draw the picture, I think it's kind of obvious. What is it? On this picture, you should always assume the ground is level and the building or cliff face is vertical unless we say otherwise. Write in all the numbers you're given and write in the one you want to find. And then sometimes some of the other things are obvious. Like I know this side immediately if I want by the Pythagorean theorem. And this problem, no, it doesn't help me. It doesn't, I don't need it, that is. Instead, what I'll do is I'll say I'm trying to find theta, so I'll write a trig relation that relates to numbers I know and theta that I want. And I'll say tangent theta is opposite over adjacent. Tangent theta is 50 over 100. Equivalently, tangent theta is a half. So now I ask, what is theta? In a triangle where you have trig function equals a number, in a right triangle, theta is always the inverse trig function. Why is it always the inverse trig function? Because the angle that has this particular tangent has to be acute, right? In a right triangle, these are both less than 90 degrees. And so they're going to be in the first quadrant, but the inverse tangent is the angle in the first or fourth quadrant that has this tangent. So the answer is always going to be the first quadrant result. In other words, triangles are only first quadrant angles. First quadrant angles, the inverse tangent that does the tangent. So the answer is arctangent of a half. And we just run that on the calculator. Now I want to put it in degrees mode, suppose. So I'm going to switch the calculator over to degrees. And push second tangent, 0.5. And now I'll get that this is approximately 26 well, let's say first it's 26.565 and a bunch of other stuff degrees. Round it to 2 decimal places, we say it's 26.57 degrees since this is bigger than equal to 5. All right. We've got about time for one more problem is all I think. Is there anything in particular someone's been looking at you want to see? I think this does a pretty good job of covering the main problems I want to put on the exam. I haven't written it yet.
Can you look at a problem on review that has something to do with like tangent, like as far as graphing it? I find it looking for that.
Yeah, we can either graph the tangent or find the equation that goes with the tangent graph. Which do you prefer?
Find the
Find the equation, okay. That would be 4a. On 4a, I might have to do this rather quickly. This is a little longer problem than the time I have. I notice there's an asymptote right here, x equals pi over 3. This is a good question, by the way, because I think this is hard. I thought it was one myself, but I was afraid of the time. And then x equals minus 5 pi over 3 is another asymptote. And it comes down like this. And these are the things we know exactly are the asymptotes. Although you can kind of see some other stuff. And then it repeats, right? It comes down here. And there's another unlabeled asymptote over here. But I know what it is, actually. How can I find the equation of this? you can use either a tangent or a cotangent, because remember the cotangent is just the tangent flipped upside down. And actually, the cotangent comes down like this, so in that sense, maybe you want to do a cotangent equation. I usually prefer to do a tangent because it's, you know, the one that's on your calculator and all, and that everybody's used to using. So I'm going to do this as a tangent, but cotangent is just fine too. Using tangent though, this has to be flipped upside down. So this is a graph of y equals a tangent bx minus c plus d. Flip because it's right, it doesn't go up to the right, it goes down to the right. What does flipped upside down mean?
Asymptotes maybe.
It means that A will be negative is what I'm getting at. All right, the stretching factor. Now also, I know the asymptotes. From that I can deduce the period. What's the period? It repeats this over and over, right? So the period is on the tangent. The period is the distance between the asymptotes. This one. What is this period? You can read it right off, actually.
It's negative pi over 3 is greater than or less than or equal to your beta.
You just subtract. You take the bigger number, pi over 3, subtract the smaller number, minus 5 pi over 3, and you get 6 pi over 3, or 2 pi. So it's 2 pi between these two, just the difference in x coordinates. There's the period. So period is 2 pi, and I think what you're getting at is 2 pi is always, or the period is always, for the sine and cosine, it's 2 pi over b, but for the tangent and cotangent, remember it's pi over b. Because the natural period of tangent is pi, the period of the stretch and shifted one is pi over b. So we know that pi over b equals 2 pi, because this was the period we look at up from the asymptotes, and this is always true for a tangent is the period is pi over b. That tells us something, right? Now we can divide this through by pi and get 2 equals 1 over b. And flip these and get b equals a half, right? Taking reciprocal. So b is a half. Now, what's the shift point? The shift point has to be halfway between the asymptotes. So we'll say if this is pi over 3 and this is pi over 3, we can average these. We can take pi over 3 plus minus 5 pi over 3 over 2 and compute it. Or what's even easier, halfway between negative 5 and 1, right? It's negative 5 pi over 3 and 1 pi over 3, halfway between is negative 2 pi over 3, right? Negative 2 halfway between negative 5 and 1. So this, if you average these, is minus 2 pi over 3. And it goes through 0, so the point is minus 2 pi over 3. I'm sorry, I must be a little in here. 0. And so now, from the shift point, we deduce that C over B, the horizontal shift, is minus 2 pi over 3, and D, the vertical shift, is 0. There's D equals 0, that gives that one. Now C over B is this, but B is a half, so this says C over a half equals minus 2 pi over 3. I can multiply both sides by a half and get C equals a half times minus 2 pi over 3. The 2's cancel. And I get minus pi over 3. So there's C is minus pi over 3. And then finally, A, you kind of have to look at this graph and say, well, it looks like halfway between the asymptotes it is about 1. If so, the point halfway between, I'm sorry, the crossing point of the asymptote tells you the shift factor. If it's about 1 here, then A equals 1, absolute value of A equals 1 from the stretch factor. But whatever it's at halfway between the crossing and the thing. But A, it has to be negative because it's flipped, so you have A equal negative 1. Now what we should have, then hopefully this matches the answer on the back. Y equals minus 1. That's A. Tangent B is 1/2. X minus C is minus pi over 3. Plus D is 0. you can simplify that y equals minus tangent 1/2 x plus pi over 3. There it is. Hopefully that's what's on the back. Should check this, I guess, huh? That's 4a. Yeah, that's what it looks like. Okay. So there's the answer to 4a, one of the hard ones. Thank you, everybody, for showing up today. Have a nice rest of your day. I have this recording if you want to go back and look at it online later.